part. So we have finished completely about the angular parts. Now we'll go for the radial part, which we have taken from the equation 2.260 earlier, correct? We have equated this factor into lambda, correct? Can you remember? Radial part into lambda, theta part into lambda. So we have taken from that equation, and this equation becomes 2.279, exactly like this. So now you have separated r part, theta part and phi part. The solution of this radial part is given by Legger differential equation, so Legger polynomial. So this is where Legger differential equation, the solution will be Legger polynomial, which is given by this expression. Okay, so this is a lengthier expression, it's out of syllabus for you, and already we have studied also in mathematical physics, so we can get that solution here, we can apply. Is it okay? So your Legger differential equation, Legger polynomial, and this is L of L. Can you remember this one? L stands for Legger polynomial, and your A0 stands for Bohr radius, which is very, very important. So 4 pi epsilon naught h bar square divided by me square. You substitute for epsilon naught 8.85 10 power minus 12 SI unit, and your h bar will be h divided by 2 pi. Your h will be 6.63 into 10 power minus 34. M stands for 9.1 10 power minus 31 kgs, and E equals 1.6 10 power minus 19 coulomb. You substitute, you will get 0.53 into 10 power minus 10 meters, you will get 0.53 angstrom. Okay, this is experimentally obtained by Niels Bohr. Okay, 1913. So that's why it's named after Bohr. Okay, Bohr radius. Okay, and later it was verified theoretically by Schrodinger. We will see now. Okay, that's the beauty of quantum mechanics. Okay, he said 0.53 will be the fixed radius, whereas Schrodinger will say it may be 0.53, or it can be less than 0.53, or it can be more than 0.53, but 90% of the time it will be 0.53 angstrom. So this was a statement made by Schrodinger beautifully. Okay, so we are going to take only 90% and 95%. The complete solution of Schrodinger equation for the hydrogen atom is given by the product of radial part and angular parts. We know already. So we have already done this one. We have obtained the radial solution, we have obtained the theta solution, we have obtained the phi solution earlier. You just put all the solutions here. So your R of R will be this one, your theta of Lm will be this one, your phi of M will be this one, correct? So this is a complete solution of wave function of Schrodinger equation for the hydrogen atom. So this was done by Schrodinger, okay? Done by Schrodinger, because we have used a Schrodinger wave equation. We recognize Niels Bohr, okay? So just look at the equation right hand side. It depends on N, L, M. Look at the factor, it depends on N, depends on L, of course, everywhere L is there, depends on L, as well it depends on M also. So all the three quantums it depends on. So okay, principal quantum number, orbital quantum number, and magnetic quantum number. Okay, is it okay? Okay. So the total wave function psi indicates that the wave function of the electron is specified by three quantum numbers N, L, M. The wave function appears complicated but reduces to simple form for low values of quantum numbers. Of course, for hydrogen atom it is easier. For helium atom also Bohr found out the value, Bohr radius, he also found out. Whereas for the complex system it was very difficult for him to find out. But Schrodinger, he derived for all the equations, all the complex systems. So that's why it is given as this statement. The solution of differential equation leads to the formula for the energy is given by this expression, minus ma to the power 4 divided by 32 n squared epsilon naught squared h bar squared pi squared. See, look at this expression. It depends only on n. What about your L and M? This is for the ground state. Okay, energy. Look at the energy. It comes around only this expression. It depends only on n. For all the complex system, the expression will depend on L and M. Okay, you substitute all the values here. You will get minus 13.6 divided by n square electron volt. You substitute all the values. Just now we said all the values, correct? So you will get this value. Even this m stands for mass of the electron. Suppose we take relative then you will have to include the mass of reduced mass, the value of the reduced mass. Suppose if you instead of m, if you substitute mu, 1 by mu equals 1 by me plus 1 by mp, mass of the electron and mass of the proton. You substitute, you will get the value. That value will differ by this value only by 0.03%. So that's why we always go with m itself. Okay, in some other books you may find that this instead of m, mu will be there. The value will be very, very small. Okay, difference of value will be very, very small. So your En will be at the end we have obtained minus 13.6 divided by n squared electron. So it depends on n. If you go for n equals, so and minus sign exists, correct? There's a minus sign. It means that electron binds with the nucleus. It's a bound value. If it is plus, unbound value. Minus sign exists. As n goes very, very high value. For example, n equal to 1, we will get E1 equals minus 13.6 electron volt. Suppose if n equal to 2. So we will go for minus 13.6 divided by 4. You will get 3.4 electron volt with a minus sign. As n increases, the energy also increases negatively, correct? So minus sign. And at the end, at n tends to infinity, this will become 0. After this will become positive value. Is it okay? So this is what it's given as like this. So negative sign says the electron is bound to the nucleus. It binds with the nucleus. Positive means unbound. As n increases, the energy tends to 0. Okay? Just now we discussed. For n equal to 1, this becomes exactly like this. Is it okay? Now we just analyze only one property. So this is just, we will take the radial part. We have already discussed about the radial part earlier, and this is E minus V, it was there. Instead of V, you can substitute minus E squared by 4 pi epsilon naught R, correct? So attractive force, radial force, okay? Now this kinetic energy can be separated into two, because electron revolves around the nucleus about its proton, correct? When it revolves on the nucleus, it must have the radial equation as well orbital equation. Radial motion, that will be radial equation. And also it moves around the nucleus. So it must have some kinetic energy of the orbit. So that's called the orbital. So your k radial, this kinetic energy can be separated into k radial plus k orbit. But this is the radial equation, correct? This is radial equation. And what are the attractive force? That also will act along with the radius, correct? Along with the radius vector. So both will get cancelled. Both are equal, correct? Your k radius and v will get cancelled. So there exists only these two alone. So these two alone. So we can equate these two apart. We have k orbital equal to h bar squared L into L plus 1 divided by 2m r squared. We are going to find out what is L into L plus 1. We are going to have the expression beautifully. Now we know already kinetic energy k orbital equal to, we know already this expression, half m squared we know already. And also we know that angular momentum L equals mvr, that also we know already. Angular momentum is nothing but your L equals r cross p, p into r, p equals mv, so mv into r. So this is your L. Okay, we know already. You just square it. So squaring, that will give you L squared, m squared, v squared, r squared. Now I am going to divide both sides by 2 first. I am going to bring this m and r squared this side. So that will give me L squared divided by 2, correct? And your only 1 m. So 1 m and r squared. Remaining part will be m v squared by 2. So which is nothing but half m squared. Half m squared is nothing but half k orbital, correct? K orbital is nothing but this one. So your L squared by 2 m r squared equal to this part. Is it okay? You compare these two. So L will be your L squared will be h bar squared L into L plus 1. Is it okay? The eigenvalue of the angular momentum is nothing but this value. Very important one more question. Eigenvalue L squared is an operator, like Hamiltonian operator. L squared is also an operator. So L squared acting on psi will give you this eigenvalue with a wave function. Is it okay? So eigenvalue of L squared is given by this. The quantized, so it means that the angular momentum, this is angular momentum, this is orbital quantum number. L stands for orbital quantum number. Your L stands for orbital angular momentum. So it implies that L equals 0, 1, 2, 3. It implies that your capital L is quantized. This was the prediction given by Niels Bohr, 1913. After 10 years only it was proved. So this fulfilled the concept of de Broglie's hypothesis. This fulfilled. Okay, so that L is also quantized. So energy is quantized. Just now energy is quantized. So look at your N. For each N you will have different values of E. For 1 we have minus 13.6 electron volt. For N equal to 2 we have different values. Minus 3.4 electron volt. Correct? For N equal to 3 you will have minus 13.6 divided by 9. Then 16. Different values of N we will have different values of energy. Similarly, different values of L we will have different values of L. So this is also quantized. L also is quantized. Prediction done by Niels Bohr earlier. Okay, now we'll go for the ground state wave function. Ground state wave function is given by that quantum numbers values n equal to 1, L equal to 0, m equal to 0. For any ground state wave function, we'll have to describe exactly all the quantum numbers like this. Okay, now we'll go for first. We'll calculate now phi of phi. Phi of phi we know already this one, this expression. Phi part we know already this. For m equal to 0, you substitute m equal to 0, you will have phi 0 which is equal to 1 divided by root 2 pi. M equals 1, you will have this. Phi 1 equals 1 by 2 pi root of e power I phi. M equal to minus 1, you will get this. M equal to 2, you can have this expression. Correct? Very simple one. Now, for the same thing, okay, n equal to 1, L equal to 0, m equal to 0, we will go for the theta part now. Theta part expression for theta part is given by this expression. Correct? Where epsilon will be minus 1 to the power m. Okay? So, this expression. And this part is nothing but your CLM, normalization constant, CLM. So, first we will take for this condition, we will take CLM. L equals 0, m equals 0. Your CLM will be C00. Is it okay? Minus 1 to the power m, this one. So we are going to substitute for L equal to 0 and m equal to 0 in this expression. You substitute 2L becomes 0, then 1 multiplied by 0 minus 0 factorial, 0 factorial, 0 factorial is 1. 1 factorial is also 1, 0 factorial is also 1. So you have 0 factorial divided by 2 multiplied by 0 factorial. Simplifying you will get 1 by root 2. So this coefficient becomes 1 by root 2. Okay. Now we have to calculate this part, PL mod m cos theta part. That we can consider this as x according to Legendre polynomial. Okay. So 1 minus x squared to the power mod m by 2 d to the power m divided by dx to the power m, which you have already studied in MP mathematical physics, PL of x. This PL of x can be calculated by using Rodriguez formula. Okay, this PL of x can be calculated using Rodriguez formula. Okay, now we will calculate this. First we will calculate this alone. Here 1 minus x squared, instead of m you substitute 0 here, mod 0 by 2. So d to the power 0 divided by dx to the power 0. Anything to the power 0 is 1. So everything will become 1 here. Now we will go for P0 of x. PL of x is given by this factor, correct? You substitute L equal to 0 here. So you have 1 divided by 2 to the power 0, 0 factorial. Again anything to the power 0 is 1, you will get 1. So this answer will become 1. And totally we have P00 of x will become 1. Okay, already we calculated theta. So L equal to 0, m equal to 0. You have pi part will be 1 divided by 2 pi. So we have already calculated 1 divided by 2 pi. Your theta will be this must be equal to 1 by root 2. This must be equal to 1. Multiplying these two will give you 1 by root 2. So 1 by root 2 multiplied by 1 by root 2 pi. Root 2 will give you 2. So 1 by 2 root pi. Is it okay? So this is for the angular parts, spherical harmonics. Okay. So your y and theta comma phi equals for L equal to 1. So this is 1 by root 2 pi. So we have already calculated. Similarly, you can calculate for L equal to 1, M equal to 0. You will get exactly like this. You just try. So that will be your assignment. For L equal to 0, M equal to 0, we have calculated. We just follow the same procedure to get the values for L equal to 1, M equal to 0. You will get exactly this expression. So that will be your assignment. Okay, similar thing, similar procedure. So we have calculated now 1 divided by root 2 pi for your spherical harmonics. Now we will go for radial part. Radial part is given by this. Wave function is the product of radial part and spherical harmonics, correct? So we have calculated the angular parts earlier. The answer is 1 divided by 2 root pi. Now we will calculate for the radial part for n equal to 1, L equal to 0, M equal to 0. You substitute. This is for the ground state. You substitute for n equal to 1, n equal to 1 here, L equal to 0, M equal to 0. You will get exactly like this. So this is your Laguerre polynomial. So the answer for Laguerre polynomial will be 1. L of 1 equal to 1. So you just simplify, you will get exactly like this. So a radial part is given by this expression. Okay. So radial part multiplied by theta part multiplied by phi part will give you this. Is it okay? Your radial part is here multiplied by your theta part. Theta part already we have calculated 1 by root 2. Phi part already earlier we have calculated 1 by root 2 pi. So we have calculated. Root 2 that will give you 2. Okay. Pi and a0 to the power 3 under root. So I have taken exactly under root 1 divided by pi a0 cube. Remaining thing will be e power minus r by a0. So this is your complete ground state wave function. Okay. This is your complete ground state wave function. Wave function for the ground state. Is it okay? So this is for n equal to 1, L equal to 0, M equal to 0. Anything? Any doubt? It's very simplified one. So now we'll solve one problem. Calculate the value of R at which the radial probability density of the hydrogen atom reaches its maximum value for n equal to 1, L equal to 0 and M equal to 0. So we are going to calculate the value at which the radial probability density. We are going to use in a different way. Okay. We know already this expression. The wave function, we know already this expression, correct? The wave function for the ground state, which is given by, just now we calculated, correct? We know already this expression. We'll just calculate for the probability density. We'll go with the probability density. The probability density is given by the square of the wave function. This is your probability density, correct? Square of the wave function, which is nothing but d tau is there. So it stands for radial part and the angular parts. So your radial parts and the angular parts. In spherical polar coordinates, it is given by r squared sin theta dr d theta d phi in spherical polar coordinates. First we will go for theta part. Okay, sin theta. I have already told you that the limits for theta will be 0 to pi, correct? So your theta to pi sin theta d theta will be minus cos theta 0 to pi. So to remove this minus sign, just change the limit, correct? Remove the minus sign. So that will give you cos theta pi to 0. Okay, cos 0 is 1, cos pi is minus 1. Already one minus is there. So 1 plus 1 answer will be 2. So this part is over now. And of course d phi part 0 to 2 pi, d phi part will be 2 pi. 2 multiplied by 2 pi will give you 4 pi. So we have calculated the angular part, spherical harmonics will be your 4 pi. Now with the radial part alone, you have r squared is here, radial part, the radial part is that one, this one, you just square it, okay, square it, you will get, you just square it, it will give you 1 by 4. Root pi multiplied by root pi will give you pi. So I have pulled out pi. Is it okay? So 1 by root of a0 cube will be squaring. You will have a0 cube. Squaring the exponential function will give you e power minus 2r by a0. Is it okay? This expression. 4 pi gets cancelled. The remaining term, you will get 1 by a naught cube e power minus 2r by a naught multiplied by r square. The complete answer for the probability density is given by this. Now we are going to use another technique to get the Bohr radius. The technique is like this. This is what Schrödinger did. We are going to have the maximum radial probability density. Okay, maximum radial probability density. How to get the maximum value for or minimum value? You just differentiate this one and it is equal to 0. Okay, differentiate this with respect to r, for which you are going to find out, and equate to 0, and you can get the maximum or minimum value. So this is what we usually will do. So you differentiate, which is equal to 0. So differentiating this, you will get the answer exactly like this. We'll see. 1 by a naught cube is constant. You pull it out. Now we have r term is here. Here you have r term. Keeping this as constant, you will have to differentiate. Keeping this as constant, you will have to differentiate. Add these two. So first we will keep this as constant. E power minus 2r by a naught. Differentiate this. That will give you 2r minus. You will have to differentiate this. Correct. So keep e power minus 2r by a naught. Differentiating this will give you minus 2 by a naught. Keeping this as constant r square. You pull the common terms out. So we have made the common terms out. E power minus 2r by a naught. So which is equal to 0. So we have equal to 0. So these terms will not be equal to 0. Only this term can be equal to 0. That will give you 2r minus 2r square by a naught. You bring this term to that side. 2 will get cancelled. R and r square, 1r will get cancelled. You have r equal to a naught. So radius of the hydrogen orbit exactly is equivalent to f Bohr radius. A naught is a Bohr radius. Okay, a naught is a Bohr radius. Beautifully done by Schrödinger. So maximum probability density exactly lies at the Bohr radius. So this was the statement made by Schrödinger. Bohr fixed the Bohr radius. 100% of the time the electron will be only at the Bohr radius, 0.53 angstrom. Whereas Schrödinger said only 90% of the time the electron will be at the Bohr radius, or 95%. The remaining times it will be either it can be close to the nucleus or it can be away from the nucleus. But most of the time only it will be only at the Bohr radius. That's why we always take the Bohr radius exactly a naught. Is it okay? Bohr radius. So maximum occurs at a distance equal to the Bohr radius from the origin. So this is what Schrödinger's diagram for the radial probability density for the hydrogen atom. Erwin Schrödinger, 1926, in the month of February he published a paper, and then onwards 4 papers he published. So this graph. So this is about radial probability with respect to your distance from the origin to the orbit. Okay. So first we will go for n equal to 1, L equal to 0, m equal to 0, ground state wave function. We now discuss that a naught, your r, this is your r, radius, r becomes a naught. You just find out this is your oneness wave function. Find out the maximum value. The maximum value is exactly lies here somewhere, which is nothing but at r equals a naught, maximum value. So 90% or 95% of the times electrons will be around this point, around a naught. Okay, this graph makes very clear supportive of Niels Bohr's experimental idea. He said 100%. He said 90 or 95%. For the next one, n equal to 2, L equal to 1, m equal to 0. This is for the 2p state. You just do it. The same procedure you will have to follow. Same procedure. You will have to find out the probability density and get the value, get the wave function. You will get exactly like this. Okay, like this. You will get it. So this is your assignment. Okay, assignment 2. You will get exactly r equals 4a naught, the next Bohr radius. Earlier r equals a naught, first one. For n equal to 2 you will get r equals 4a naught. For the next one, it will be R equals 9A naught, 3 squared, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, correct? 9A naught. So that will be your Rn will be n squared A naught. Okay, is it okay? So now R equals 4A naught. This is your 2p state, correct? This is your 2p state. The maximum probability, highest probability lies somewhere exactly at 4A naught. So maximum value, maximum times 90%, 95% times the electrons will lie at this state only at 4A naught. Okay. So all the allowed values of atomic radius is given by this expression. So this also is quantized. Your Rn also is quantized. Energy is quantized, which just now we said. Then angular momentum also is quantized. Now radius also is quantized. See, in a fixed orbit. When the electrons in a fixed orbit, they will never emit radiations. This was a statement made by Niels Bohr. It will never emit radiations. Only when it jumps from upper to lower. When it goes from lower to upper, it will emit some radiations. So this was the evidence given by Niels Bohr, the emission of hydrogen atom. So quantized radii of circular orbits for hydrogen atom, Niels Bohr. It gives the location where the probability density of finding the electron reaches maximum by Erwin Schrödinger. Okay. So that's all we have done so far. So this is for the hydrogen atom, and two different scientists, they have made the quantum mechanics successful. So one contribution was given by Niels Bohr, experimental factor. It was supported by Schrödinger theoretically. So one was deterministic, another one is probability nature. So thank you, students. We'll see in the next class.